Hey, this is Mr. Barr, and these are the notes. The newts. Oh my goodness, Mr. Barr. I had to restart this video because I messed it up so horrifically the first time. So these are our notes. Start with your name. Name. And the title is Roots. And we're going to start with a root that we already know how to do. It's a square root. So the square root of 16, which could also be written as the square root of 16. Notice the little 2, no little 2, it means the same thing. If there's no little 2, it's still a square root. If there's the little 2, it's still a square root. So what is the square root of 16? The square root of 16 is 4. And that's because 4 times 4 is 16. 4 times 4 is 16. Can we do that on a calculator? Yes. So let me pull up a calculator. So I would Google for a scientific calculator. And here's one that comes up, the Google one. This one is not going to be good enough for us. The Desmos one is going to be better. So I'm at desmos.com scientific. That one's looking pretty good. And you'll understand why in a little bit. So let's go with the square root of 16, and the square root of 16 is 4, because 4 times 4 is 16. But what if it's not a perfect square? What's the square root of 30? Well, I'm going to use the calculator. Square root of 30, let's come back to my calculator. Square root of 30, 5.477, which I'm going to round to 5.5. So the square root of 30 is 5.5, rounded. So that's it for square roots, but let's look at cube roots. So what's the cube root of 27? What times itself 3 times is 27? Well, 2 times 2 times 2 is 8, so it's not 2. 3 times 3 is 9, times 3 is 27. So the answer to this is 3. Well, can we do it on a calculator? Yes, we can. We're using Desmos because it has this function right here, n to the root. So I go, see, click that, cube root of 27 is 3. Notice I had to put the little 3 there. See that little 3? I have to have it there, otherwise the calculator doesn't know that I want to do a cube root. If I don't put anything there, it's going to assume that it's a square root. Well, let's do one that's not a perfect cube. Let's do the cube root of 100. Not the square root of 100, the cube root of 100. Let's go to our calculator. Cube root of 100. They're all cube root of 100. I almost did the 31st root. Cube root of 100 is 4.6. Cube root of 100 is 4.6. Now we can actually do square roots, cube roots, fourth roots. I'm going to do a fourth root right now with you. And we'll even do a fifth root. But you could do any root that you want with a calculator. So let's do a fourth root. Of 98. And then, you know what, let's go with a fifth root of 1000. And we'll put these both in our notes. The fourth root of 98 and the fifth root of 1000. The fourth root of 98, well, let's go find that. Fourth root of 98. Put it like that. Oop, I can't get it out of the way, can I? Fourth root of 98. Fourth root of 98 is 3.14. Check that out. It turned out to be pi. Almost pi. 3.14. It's pretty close to pi. The fourth root of 98 is 3.14, or with the correct rounding, it'd be 3.1. How about the fifth root of 1,000? Fifth root of 1,000, clearing all. Fifth root of 1,000. Nope. Is 3.98, which would round to just 4. So it would be 3.98, which is just a 4 because of the rounding. All right, that's it for your notes. I'm going to do a couple practice ones with you if you want to play along. If you're watching this live, you can do this with me, and I'll just keep that calculator open. And we can just make these up all day long. Let's see what happens here. Where am I? Let's go with the square root of, pick any number, the square root of 387. The square root of 387. Square root 387. 19.7. 19.7. All right, how about, let's do a cube root. The cube root, have to put that cube there, of 768. Cube root of 768. Cube root of 768. 9.2. 9.2. How about the fifth root? Let's go with a seventh root. The seventh root of, let's see, the seventh root. Why am I not drawing? Here we go. The seventh root of 1,223. Seventh root of 1,223. Seventh root, 1,223. 2.76 or 2.8, 2.8 with the rounding. All right, hey, thank you for watching and have a great day.